Hi friends, welcome to our channel. Let's have a look at problem 3607, power grid maintenance. This problem can be solved using UniFind or using traversal. For example, depth first traversal or breadth first traversal. Here, let me first make some annotations. So the strategy to solving this problem is the following. First, you find the connected components, and then basically, in order to know to solve get the return, so you need a way to know for a node or for an index which connected component it lies in. So we need to name each connected component. I'm going to use CC. So this is the one. And once you have this, so because here, so for 1x, a maintenance check is request for station X. If station X is online, so it resolves the check by itself. Otherwise, the check is resolved by the operational station with the smallest ID in the same power grid as X. So here, actually, a power grid, the power grids form a connected component. You can regard this two concepts, the grid and the connected component or cluster in the language of UniFind. The same thing, right? So because we want to have a smallest ID, so here we need some sort of sorting or using data structure. So you can use say sorted set, right? So this is the main strategy. So here for finding the connected components, so typically there are two ways, like we use UniFind or traversal. So for traversal, you can use DFS or BFS. Both are okay. So in this video, I'm going to use UniFind to get all the connected components and then prepare the return. And in the follow-up video, I'm going to address the the problem of finding connected components using traversal. So with that said, let's look at coding. So first, I'm going to have roots. So its roots is going to be a list of from, so here from 0 to say just write C+1. So here, because the problem is that the index is van-based indexing, right? So we have the C power stations. So the number is from 1 to 2 up to C. So we should have index up to C. So this is just one way, right? You can use index I to represent power station I+1. So that way you just need to use a list of length C. But here I'm using the list of length C+1. So this just using index I means the station I, right? So this is another one is rex, right? So it's originally the size of each of the station is just 1 itself. So we can multiply by C+1. Here also I'm going to use rex I to represent the size of the grid, power grid, in containing power station I, right? So here, this is the interpretation of rack, right? So sometimes when you use UniFind, it might have different interpretations. Overall, you need to design these roots or racks according to the problem need of problem logic. So with these two variables given, so we can write the find method and the union method. So find. So given a power station, how to find its root or the representation of the cluster or connected component it lies in. So here, this is very standard, right? So we have roots I. So val result does not equal to roots result. Then I'm going to set result to be roots result, right? And then basically you just return the result. So after the end of this while loop, so we are going to have result equal to the roots of result. Then this is the thing we want to return. But also we want to add something called path compression. So you can see here. So we set the roots of the current result to be the roots of the roots of the result. This is one way to implement path compression. So this is the find method. Now let's look at the union method. So with the find method given, so given two power station or two nodes, so how do we get the combine the two so that they are belong to the same cluster or connected component? So here we can first get the root I, root j. So we can call the find method find I, find j. So if the roots are the same, so we do nothing. Otherwise, so if root I does not equal to root j, so what we can do, so we can directly set the root of root j to be root I, and that's it. So that's the vanilla union. But we want to use union by rex. So if rex root I is greater than or equal to rex of root j, then we are going to combine. We are going to set the roots of root j to be root I. Of course, this you can imagine as we merge the smaller cluster to the larger one, right? So then the correspondingly the size or the rank of root I is increased by that of root j. Symmetrically, you can do the following. Let me copy these two lines, and we set the root of root I to be root j, and correspondingly the rank of root j is incremented by that of root I. So this is the union method. So once we have the find and the union, so we can build the clusters. In other words, we can find the corresponding connected components. So for this, let's see, for UV in connections. So we just need to union them. Notice that in the union function, the UV is symmetric, right? So in other words, union of UV is the same effect as union of VU. So this actually corresponds to, undirected graph, or you can see bidirectional graph. So this is the one thing. So now, once we union all these things, so we can get the corresponding result clusters. So here, let me write a function in order to do that. So, so here in this clusters, I'm going to set the roots as the root, and then each root I'm going to set corresponding cluster nodes as a sorted set. So here get clusters or get connected components. So we don't need to provide arguments. So here what I'm going to use is collections default dict. So I'm going to supply them sorted set, right? So this way, so this container is maintained a sorted order, right? So this way we can see the smallest index. So basically for I in range, so 1 C plus 1, right? So this is the power station. So let's first find the root. It's going to call find, right? Roots of this power station. And then what we do is D of this root. So we're going to add, notice that DR is a sorted set. So we're going to add the current station, right? So what we want to do is to return this D, right? So now actually you can call this function first. So what's the information we get? So get clusters So let me print out this information. For example, in example 1, so it forms a singly connected one. So we have a name 1, right? So the nodes are 1, 2, 3, 4, 5. So in case 2, so because they are isolated essentially, so we're going to have this 3 clusters, right? So now we are ready to prepare the return. So in order to prepare the return, let's write a result. This is the thing we are going to return. So first for canned, right? So what clusters it has? IDX in queries. So it's here canned is either 1 or 2. So 1 means we need to do a maintenance check. 2 means that we want to make the X offline, right? So first, let's find the root, find IDX. So once you find this root, you find the cluster representation, right? And then first, if canned equals 2. So here we want things to go offline. So we get info, so this cluster, right? So we need to discard this IDX. This corresponding to IDX goes offline. So actually this discard function is very elegant. So because if you use remove, if IDX not in that cluster or it's already offline, so you will get some errors. But discard, so if IDX not in the sorted set, it just return as performs, right? So this is also the difference of discard and the remove method for the sorted set. So this is the one. And another one is that the canned is 1. So we need to do a maintenance check. So here the logic is very important. First, if not info R. So in other words, the cluster actually is empty. So in this case, by problem requirement, we need to append -1, right? Otherwise, so we still need to consider 2 possibilities. Either X is online and inside the cluster, or IDX. Otherwise not. First, if IDX in info R. So like you see here, if station X is online, it resolves the check by itself. So in this case, we append IDX itself. Otherwise, so we need to return append the smallest index on online power station. So in other words, we need to append info R0. So that's actually why we use sorted containers. Here we use the sorted set because in the sorted set, it contains in every when we look at each query, the current online power stations with that cluster, right? So now we just need to return the results state. So this is actually a full solution. Now let me first run it. Yeah, it passes the 2 test cases. So now let's look at the generic case. Let's submit that. Yeah, it passes all the cases. So before we end this video, let me first make some comments. The important point here is that we can decompose this problem into smaller problems. So here we actually decompose the whole problem into 2 at least. So one is to find connect component. Another one is how to prepare the return. In order to prepare the return, sorting is involved. So here we use SortedSet. Actually, you can use sorting, but it's more evolved. So with that said, that's basically the main content for this video. In the next video, we're going to look at this problem again, but we're going to use traversal. to address that. So with that said, that's it. Thank you for watching.